We'll start in a minute. Today we'll finish section 9.3 on double angle, half angle, and reduction formulas. And then after that, we'll go over the test 2 review. We'll over Chapter 8 and sections 9.1 and 9.2. Test 2 is on Monday, July 27th from 11 a.m. to 11:50 a.m. So you can start test 2 a few minutes early, like 10:45, just like we did this week. Okay, we'll use the reduction formulas to derive half-angle formulas. So we recall what the reduction formula is for sine of theta squared. It's 1 minus cosine of 2 theta divided by 2. So we let theta be equal to alpha over 2. Then 2 theta is equal to alpha. And then we make substitutions, replace theta with alpha over 2, and replace 2 theta with alpha. We get sine of alpha over 2 squared equals 1 minus cosine of alpha over 2. And so the first half-angle formula, when we solve for sine of alpha over 2, sine of alpha over 2 is equal to positive and negative square root of 1 minus cosine of alpha over 2. Okay, so this is the first of the half-angle formulas. Then a similar type of thing will be used to derive the next half-angle formula. We recall from yesterday that cosine of theta squared is equal to 1 plus cosine of 2 theta over 2. And then just like in the previous derivation, we let theta be equal to alpha over 2. And that means that 2 theta equals alpha. So we replace theta with alpha over 2 and replace 2 theta with alpha. So we get cosine of alpha over 2 squared equals 1 plus cosine of alpha over 2. And then our second half-angle formula, cosine of alpha over 2 is equal to positive and negative square root of 1 plus cosine of alpha over 2. And we also have a half-angle formula involving tangent. Tangent of theta squared is 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta. So we simply got this by dividing the reduction formula for sine of theta squared by cosine of theta squared. Okay, so we let theta be equal to alpha over 2. So 2 theta is equal to alpha. Then replace theta with alpha over 2. Tangent of alpha over 2 squared is equal to 1 minus cosine of alpha divided by 1 plus cosine of alpha. And so we can write tangent of alpha over 2 is equal to the square root, I should say positive and negative square root of 1 minus cosine of alpha over 1 plus cosine of alpha. But for the half angle formula involving tangent, we can take it a step further. We're going to multiply by 1 in the form square root of 1 minus cosine of alpha over 1 minus cosine of alpha. So we're just multiplying by 1. So we get positive and negative square root. So in the numerators of the square roots, 1 minus cosine of alpha times 1 minus cosine of alpha, I'll just write that as the quantity 1 minus cosine of alpha squared in the numerator. And in the denominator, let's just write down what we get when we multiply 1 plus cosine of alpha times 1 minus cosine of alpha. When you multiply those two and simplify, you get 1 minus cosine of alpha squared. And 1 minus cosine of alpha squared is sine of alpha squared. So we get positive and negative square root of the quantity 1 minus cosine of alpha squared over sine of alpha squared. And then when we simplify, we won't need the positive and negative. I'll explain why in a second. But the square root of 1 minus cosine of alpha quantity squared is just 1 minus cosine of alpha. And the square root of sine of alpha squared is sine of alpha. So why don't we need the plus and minus? So I'm claiming that we can just write tangent of alpha over 2 is equal to 1 minus cosine of alpha over sine of alpha. Okay, so note that 1 minus cosine of alpha will never be negative. The smallest that 1 minus cosine of alpha could be is 0, because the maximum value of cosine of alpha is 1, and 1 minus 1 is 0. Okay, so the numerator is never negative, but when sine of alpha is negative, then tangent of alpha over 2 is negative. And when sine of alpha is positive, tangent of alpha over 2 is positive. So we don't need the positive and negative symbols because the numerator is never negative. And when the denominator is negative, this is negative. And when the denominator is positive, this is positive. So I can explain it a little bit further. So if alpha is in quadrant 1 or quadrant 2, then alpha over 2 is in quadrant 1. And we know that in quadrant 1 and quadrant 2, sine of alpha is positive. And we also know that tangent is positive in quadrant 1. So sine of alpha and tangent of alpha over 2 have the same sign when alpha is in either quadrant 1 or quadrant 2. And then if alpha is in quadrant 3 or quadrant 4, then where will alpha over 2 be? Alpha over 2 is in quadrant 2. Okay, in quadrant 3 and quadrant 4, if alpha is in quadrant 3 and quadrant 4, sine is negative, and since alpha over 2 is in quadrant 2, tangent is negative there also. So that's an argument. Just remember this, tangent of alpha over 2 is equal to 1 minus cosine of alpha over sine of alpha. Okay, so we'll apply those formulas in an exercise. Two legs of a right triangle have lengths 5 over 12, 5 and 12, I should say, and theta is the measure of the smallest angle. So if we construct a right triangle, so we can do something like this. Theta is the smallest angle. The two legs have lengths 5 and 12. The hypotenuse, using the Pythagorean theorem, we can find that the hypotenuse is 13. So for sine of theta over 2, using the half angle formula, sine of theta over 2, that's equal to positive and negative square root of 1 minus cosine of theta over 2. Okay, but for this right triangle, we'll take the positive square root. So we need to know what cosine of theta is. So cosine of theta is 12 over 13. And so sine of theta over 2 is equal to the positive square root of 1 minus 12 thirteenths divided by 2. And we'll simplify a little bit further. 1 is equivalent to 13 over 13, and 13 over 13 minus 12 over 13 is 1 over 13 divided by 2 inside the square root. So we could write this as the square root of 1 over 26. That's an okay answer. Okay, for cosine of theta over 2, in general, cosine of the half angle, theta over 2, is equal to positive and negative square root of 1 plus cosine of theta over 2. But for the right triangle, we want the positive square root. And cosine of theta is 12 over 13, so we get the square root of 1 plus 12 thirteenths over 2 inside the square root. And we can simplify this a little bit more to get the square root of 25 over 26. Okay, then finally, tangent of theta over 2. So we'll use that formula that we just derived. In general, tangent of theta over 2 is 1 minus cosine of theta divided by sine of theta. Okay, cosine of theta is 12/13, so we have 1 minus 12/13. And in the denominator, sine of theta, is 5/13. So we divide by 5/13. The numerator, 1 minus 12/13, becomes 1 over 13, 1/13 divided by 5/13. And this will simplify to 1/5. I'll write a little bit more detail just to remind you. If you divide one fraction by another, we can multiply the fraction on top by the reciprocal of the fraction on the bottom, and we get 1/5. Okay, that's all we're going to say about section 9.3 for now. We'll go ahead and start the test 2 review sheet. Okay, first we'll start with section 8.1 material. Some of these examples are going to seem pretty complicated, but if you can follow along, the test problems will seem easy in comparison. But these are good exercises just to make sure that you know what to do in general. So we want to graph y equals 3 times sine of 4x minus 2 pi over 3 minus 2. So we need to find some things. We need to know what the amplitude is, find the amplitude. Find the period. We need to be able to find some important x values on the x-axis. So I'll just say find key values on both the x and y axes. Also find the x and y coordinates of the local maximum and local minimum values. So find xy coordinates of the maximum and minimum. So we'll try to do all of this. This one will take a few minutes to do. So the amplitude is 3. So I'll just abbreviate amplitude is 3. Since the coefficient of x is 4, the period is 2 pi divided by 4. 2 pi divided by 4 is pi over 2. We also have a vertical shift, or I should say the midline. That's the line that the curve oscillates about. And since we have a minus 2, the midline is y equals -2. Okay, so we'll use the same method for picking the the period that we want to graph this sine function. So this argument of sine is 4x minus 2 pi over 3. So we know that 0 is less than 4x minus 2 pi over 3, which is less than or equal to 2 pi. And then we solve this compound inequality for x. So first add 2 pi over 3 to both sides. So 0 plus 2 pi over 3 is less than or equal to 4x. And when we add 2 pi over 3 to 2 pi, well, think of 2 pi as 6 pi over 3. And 6 pi over 3 plus 2 pi over 3 is 8 pi over 3. Okay, and then we divide both sides, or all three sides, by 4, because we want to solve for x. Or equivalently, multiply all three parts by 1/4. So when you multiply 2 pi over 3 by 1/4, that's going to simplify to pi over 6 when you do the arithmetic. And then 1/4 times 4x is x. And then 1/4 times 8 pi over 3 simplifies to 2 pi over 3. Okay, so for one period of this sine function, we're going to graph it on the interval from pi over 6 to 2 pi over 3. Okay, so we want to divide the interval into 4 parts. And since the period is pi over 2, well, one of the 4 parts, or each of the 4 subintervals, is going to be of length 1/4 times pi over 2, which is pi over 8. Okay, so I'll go ahead and draw the horizontal axis and the vertical axis. And we'll plot pi over 6. That's going to be the left end point. And this won't necessarily need to be completely to scale, but let's evenly divide out 4 subintervals for the one period that we're going to graph. We know that this endpoint has to be 2 pi over 3. And then this point has to be pi over 6 plus pi over 8. Okay, so this point is pi over 6 plus pi over 8. So I'll do some of that arithmetic over here. So pi over 6 plus pi over 8. The common denominator is 24. So pi over 6 is 4 pi over 24. And pi over 8 is 3 pi over 24. And then when we add those, we get 7 pi over 24. So 7 pi over 24. To find this point, well, we can do one of two things. We can add pi over 8 to 7 pi over 24, or we can add pi over 4 to pi over 6. We'll get the same number either way. But let's go ahead and start with this one, 7 pi over 24. We'll add pi over 8 to it. So 7 pi over 24 plus pi over 8. Well, the common denominator is 24, so this becomes 3 pi over 24. 7 pi over 24 plus 3 pi over 24 is 10 pi over 24. And we'll write this in lower terms, 5 pi over 12. So that's the middle point, 5 pi over 12. And then to find this x coordinate for this point, we can add pi over 8 to 5 pi over 12, or add it to 10 pi over 24. So I'll use this before we reduced it, 10, because we're going to have to change it back anyway. So 10 pi over 24 plus pi over 8. So pi over 8 is 3 pi over 24. When we add that to 10 pi over 24, we get 13 pi over 24. So this point is 13 pi over 24. Okay, the midline well, I don't want to run out of room, so the midline is negative y equals negative 2. So this is the midline. And the amplitude is 3. So the minimum value, the minimum y value will be negative 5 because it has to be 3 below the midline, and the maximum value will be positive 1 because the maximum value will be 3 above negative 2. Okay, so this is just the amplitude is, well, the leading coefficient is 3. So we can check when x is pi over 6. So multiply 4 times pi over 6. That's 4 pi over 6, which is 2 pi over 3. 2 pi over 3 minus 2 pi over 3 is 0. Sine of 0 is 0, and 3 times 0 minus 2 is negative 2. So when x is pi over 6, the output value is negative 2. So this is a point on the graph. When x is 7 pi over 24, so let's do some calculations down here so we can perhaps see the arithmetic a little bit better. I'm going to replace x with 7 pi over 24, so it's 4 times 7 pi over 24, and then from that we're going to subtract 2 pi over 3. So this goes, 4 goes into 24 6 times, so this is 7 pi over 6, and then minus, we'll want a common denominator, so we'll subtract 4 pi over 6. And 7 pi over 6 minus 4 pi over 6 is 3 pi over 6, which is pi over 2. Okay, and we know that sine of pi over 2 is 1. 3 times 1 is 3, and 3 minus 2 is 1. So for this function, when x is 7 pi over 24, the y value is positive 1. So this is the first fourth of the period. It's what we expect. Okay, when x is 5 pi over 12, okay, so think about what happens when you multiply 5 pi over 12 by 4. So I'll squeeze that in here, 4 times 5 pi over 12, and then from that we're subtracting 2 pi over 3. Okay, so 4 goes into 12 3 times, so we have 5 pi over 3 minus 2 pi over 3 equals 3 pi over 3, or pi. And we know that sine of pi is 0, so 3 times 0 minus 2 is negative 2 again. So when x is 5 pi over 12, the y value is negative 2. Okay, let's do the next couple a little bit more rapidly. When x is 13 pi over 24, 4 times 13 pi over 24 is 13 pi over 6. And 13 pi over 6 minus 2 pi over 3, that's 13 pi over 6 minus 4 pi over 6, which is 9 pi over 6, which is 3 pi over 2. And the sine of 3 pi over 2 is negative 1. So 3 times negative 1 is negative 3. Negative 3 minus 2 is negative 5. So I wrote all over the graph, but when x is 13 pi over 24, the y value is negative 5. And then finally, when x is 2 pi over 3, this will be easier to compute. 4 times 2 pi over 3 is 8 pi over 3. 8 pi over 3 minus 2 pi over 3 is 6 pi over 3, which is 2 pi. Sine of 2 pi is 0. 0 minus 2 is negative 2. So there is our 1 period of that sine function. Okay, be able to label the maximum on this interval. The x-coordinate is 7 pi over 24, and the y-coordinate is 1 for the maximum. And for the minimum, the x value is 13 pi over 24, and the y value is negative 5. Okay, let's do the next problem. This one will seem easier in comparison. So, same sort of thing though. The amplitude is 4. I'll abbreviate amplitude if that's okay. The amplitude is 4. The period is 2 pi divided by pi over 7. When you do the arithmetic, you get 14. 2 pi divided by pi over 7 is 14. So that's a pretty long period. To find out where we're going to start this, we'll remember this argument, pi over 7 times x plus pi, is between 0 and 2 pi. So 0 is less than or equal to pi over 7 times x plus pi, which is less than or equal to 2 pi. Then subtract pi from all 3 parts, and we get negative pi is less than or equal to pi over 7x, which is less than or equal to pi. Then we'll multiply all 3 parts by the reciprocal of pi over 7. That is, multiply all 3 parts by 7 over pi. So 7 over pi times negative pi is negative 7. Pi over 7x times 7 over pi is 1x. And then on the right-hand side, multiply pi over 1 by 7 over pi, you get 7. Okay, so we're going to start the left endpoint at negative 7 and the right endpoint at 7. So let's suppose this is negative 7, and then about right here is positive 7. The middle point is 0. The amplitude is 4, so we have 1, 2, 3, 4. The midline is just y equals 0, the x-axis. And then we go as low as negative 4 and as high as positive 4. Well, we want to divide the period into 4 equal parts. So if we have it divided in 2 equal parts, and then this will be negative 7 halves, or negative 3.5, and then this will be positive 7 halves. Okay, so let's see what happens at the left endpoint when x is negative 7. Replace x with negative 7. So pi over 7 times negative 7 is negative pi. Negative pi plus pi is 0. Cosine of 0 is 1, and 4 times 1 is 4. So we have this maximum value. So we'll label it negative 7, 4. Okay, now let x be negative 7 halves. So when x is negative 7 halves, I think I'll be out of the way if we do the calculation over here. So replace x with negative 7 halves, and the 7's cancel, we get negative pi over 2 plus pi, which is pi over 2. And we know that the cosine of pi over 2 is 0. So to reiterate, when x is negative 7 halves, after doing the arithmetic, we have cosine of pi over 2, which is 0. 4 times 0 is 0. So this is a point on the graph, negative 7 halves, 0. Hey, we can do the next one without writing anything down. When x is 0, we have cosine of pi. Cosine of pi is negative 1. 4 times negative 1 is negative 4. So this is a point on the graph. We want to label it because it's the minimum. So 0, negative 4. Okay, and the first half of the graph we can sketch in like this. And the next two parts will be pretty simple. When x is 7 halves, pi over 7 times 7 over 2 is pi over 2. Pi over 2 plus pi is 3 pi over 2. But cosine of 3 pi over 2 is 0, and 4 times 0 is 0. So we have this point. The y-coordinate is 0. It's on the x-axis. And then finally, when x is 7, pi over 7 times 7 is pi. Pi plus pi is 2 pi. Cosine of 2 pi is 1, and 4 times 1 is 4. So we get this point on the graph. Okay, so there's one graph of the cosine function. We'll label this. This is also a maximum, 7, 4. Okay, we'll move on to the next page. Okay, on this one, we're going to graph y equals -3 cosecant of x minus pi over 2. So we're just going to graph the reciprocal function y equals -3 sine of x minus pi over 2. And for this one, we want to identify the vertical asymptotes. So I'll mention that. Write the vertical asymptotes as equations. Okay, well, the coefficient of x is 1, so the period is pi. Sorry, not pi, 2 pi. And then what interval are we going to start with? Well, we remember 0 is less than or equal to x minus pi over 2, which is less than or equal to 2 pi. Then to solve for x, we just add pi over 2 to both sides. So pi over 2 is less than or equal to x. And 2 pi plus pi over 2 is 5 pi over 2. So the vertical asymptotes are at the endpoints. So x equals pi over 2 and x equals 5 pi over 2. And then also right in the middle. So at 3 pi over 2 is also a vertical asymptote. Hey, but let's go ahead and sketch the one period of the sine function. So the left endpoint is pi over 2. Since the period is 2 pi, the subintervals are also, they're each of length pi over 2. So this will be pi, 3 pi over 2, 2 pi, and then 5 pi over 2. Okay, so the cosecant function, this particular cosecant function, when x is pi over 2, cosecant of 0 is undefined. So that's where it has a vertical asymptote. At 3 pi over 2, 3 pi over 2 minus pi over 2 is pi. Cosine of pi is undefined because sine is 0 there. And then also at 5 pi over 2, cosecant of 2 pi is undefined, so we have a vertical asymptote. Okay, but we're just going to first sketch the sine function. The amplitude for sine is 3, but the leading coefficient is negative. Okay, so for the sine function, when x is pi over 2, we get sine of 0, which is 0. And -3 times 0 is 0. So this is a point on the graph. When x is pi, we have pi minus pi over 2, which is pi over 2. Sine of pi over 2 is 1. -3 times 1 is -3. So we have this point on the graph of the sine function down at -3. at 3 pi over 2, 3 pi over 2 minus pi over 2 is pi. Sine of pi is 0. Negative 3 times 0 is 0. And for when x is 2 pi, 2 pi minus pi over 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 3 times negative 1 is positive 4. So we have this point on the graph. And then finally, 5 pi over 2 minus pi over 2 is 2 pi. Sine of 2 pi is 0. Negative 3 times 0 is 0. Okay, this is the sine function over one period. And so cosecant, well, between pi over 2 and 3 pi over 2, the graph of this cosecant function will look something like this. And on the interval between negative 3 pi over 2 and 5 pi over 2, the cosecant, this particular cosecant function looks something like that. Okay, perhaps for the sake of time, we'll just not do this one for now. If there's time a little bit later, we'll come back to it, but I'll just tell you how to get started. First graph, y equals 2 times cosine of 1/2 x plus pi over 2. And then find where the vertical asymptotes are and so on. Before I forget, up here I wanted you to be able to write the vertical asymptotes as equations. So the vertical asymptotes in this example written as equations, well, one of those is x equals pi over 2. That's the vertical line in the xy plane. X equals 3 pi over 2. And then the third vertical asymptote is x equals 5 pi over 2. Okay, so first graph, y equals 2 cosine of 1/2 x plus pi over 2. And then you could sketch the graph of the reciprocal function as a guide. Okay, so let's graph a tangent function. Y equals 2 times tangent of pi over 4x minus pi over 2. Okay, so the period for a tangent function, we divide pi by the leading coefficient. So pi divided by pi over 4 is 4. Okay, remember that just for y equals tangent of x, the common period is between negative pi over 2 and pi over 2. So for this tangent function, we say pi over 2 is less than this argument, pi over 4x minus pi over 2, which is, sorry, not, this should be negative pi over 2 on the left. Negative pi over 2 less than pi over 4x minus pi over 2 is less than positive pi over 2. And then solve this for x. First, we'll add pi over 2 to both sides, to all three sides, all three parts. Negative pi over 2 plus pi over 2 is 0. And in the middle, we have pi over 4x. And then pi over 2 plus pi over 2 is pi. And then multiply all three parts by the reciprocal of pi over 4. So 4 over pi times 0 is 0. And 4 over pi times pi over 4x is x. And 4 over pi times pi is just 4. So our primary interval will be from 0 to 4. And this tangent function does have vertical asymptotes. In this case, for our period, it will be x equals 0 and x equals 4 for the period. So the period is from 0 to 4. And tangent has a vertical asymptote. Same as the y-axis, but the equation for the y-axis is x equals 0. So be able to label the vertical asymptote as an equation of a line. And then the other vertical asymptote is x equals 4. So if you remember when we covered graphing tangent functions, we want to be able to find 3 points by dividing the period into 4 subintervals. So we want to know what the y value is when x equals 1, x equals 2, and x equals 3. Those are the 3 key points that we want to be able to find in this one. So let's just create a little chart. X is 1, 2, and 3. And then the y values are 2 times tangent of pi over 4 times x minus pi over 2. Okay, when x is 1, pi over 4 times 1 is pi over 4. Pi over 4 minus pi over 2 is negative pi over 4. Tangent of negative pi over 4 is negative 1. 2 times negative 1 is negative 2. So we have the ordered pair 1, negative 2. So this point is on the graph. So let's label it 1, negative 2. And then when x is 2, pi over 4 times 2 is pi over 2. Pi over 2 minus pi over 2 is 0. Tangent of 0 is 0. 2 times 0 is 0. So 2, 0 is a point on the graph. So 2, 0. When x is 3, pi over 4 times 3. 3 pi over 4 minus pi over 2 is pi over 4. The tangent of pi over 4 is 1. 2 times 1 is 2. So we get this point. The graph will look, it has curvature to it, so it will look something like this. Okay, graphing the cotangent function is similar to graphing tangent, but one thing that you have to be careful with for cotangent, we find the interval that we want to graph by writing 0 as less than or equal to x plus pi over 4 is less than pi. So make sure you notice the difference between finding an interval for cotangent versus finding an interval for tangent. So for tangent, we put the argument between negative pi over 2 and pi over 2. For cotangent, we put the argument between 0 and pi. So I'll just take this one step further, subtract pi over 4 from both sides. So we get negative pi over 4 is less than x. And then pi minus pi over 4 is 3 pi over 4. So for this cotangent function, the vertical asymptotes will be x equals negative pi over 4 and x equals 3 pi over 4. And then you can subdivide the interval into 4 equal parts. Why don't we take that just one step further? So we have the x-axis, negative pi over 4. Since the period of this one is just pi divided by 1 is pi, the length of each subinterval is just pi over 4. So we go from negative pi over 4 to 0 to pi over 4, 2 pi over 4, which is just pi over 2, and then 3 pi over 4. And the vertical asymptotes will be x equals negative pi over 4 and x equals 3 pi over 4. The 3 key points. So we know what those x values need to be: 0, pi over 4, and pi over 2. So the 3 key points, looks like I'm just going to graph this anyways. So the 3 key points are when x are 0, pi over 4, and pi over 2. So we do get a vertical shift out of it, but when x is 0, we get the cotangent of pi over 4, which is 1. 1 plus 2 is 3. So when x is 0, the y-coordinate is 3. So we get that point. When x is pi over 4, pi over 4 plus pi over 4 is pi over 2. Cotangent of pi over 2 is 0, and 0 plus 2 is 2. So pi over 4, 2. And then when x is pi over 2, pi over 2 plus pi over 4 is 3 pi over 4. Cotangent of 3 pi over 4 is negative 1, and negative 1 plus 2 is 1. So we have pi over 2, 1. So the graph will look like this. Okay, let's move on to the next page. From section 8.3, find the values of the following. The arc cosine of the square root of 3 over 2. This is equivalent to the inverse cosine of square root of 3 over 2. So the angle whose cosine is the square root of 3 over 2 is pi over 3, or 60 degrees. Okay, for this one, the cosine of arc sine of 1/4, we want to find the cosine of the angle whose sine is 1/4. So for this one, we can draw a right triangle to help us. So the angle whose sine is 1/4, and we want to find the cosine of that angle, so we have to find the adjacent side. So using the Pythagorean theorem, this just turns out to be the square root of 15, right? Because 4 squared equals the square root of 15 squared plus 1 squared. Okay, so the cosine of this angle, whose sine is 1/4, is the square root of 15/4. And then we have a role reversal here. The sine of our cosine of 1/4, we want to find the sine of the angle whose cosine is 1/4. So this is going to look familiar. So here's our angle. The cosine is 1/4. We want to find the sine of that angle, the opposite over hypotenuse. Well, this opposite side is the square root of 15 again. And so the sine of that angle is the square root of 15 over 4. Okay, draw the angle inverse tangent of 13 over 22. This is an angle, so how do you draw an angle? Remember that the range of inverse tangent is from negative pi over 2 to pi over 2. And tangent is positive between 0 and pi over 2. So the angle is in the first quadrant. So we want to draw an angle where it looks like the tangent is 13 over 2. So the opposite side is shorter than the adjacent side. So I'll just draw this. So if this side is 13 and the adjacent side is 22, then this angle is inverse tangent of 13 over 22. So we drew the angle. Okay, in the next example, find the exact value of the inverse cosine of sine of 11 pi over 4. So first, let's evaluate the sine of 11 pi over 4. So 11 pi over 4 is more than 2 pi. It's 2 pi plus 3 pi over 4. So we can say that this is equal to sine of 3 pi over 4. Because 3 pi over 4 plus 2 pi is 11 pi over 4. And the period of sine is 2 pi. 3 pi over 4 is in the second quadrant. The reference angle is pi over 4. And sine is positive in the second quadrant. So this is equal to sine of pi over 4, which is the square root of 2 over 2. So now we want to find the inverse cosine of the square root of 2 over 2. So the angle whose cosine is the square root of 2 over 2 is pi over 4. Okay, the next one will be perhaps a little easier. Find the exact value of the inverse tangent of cosine of pi. We know that the cosine of pi is -1. And then the inverse tangent of -1. So this is equal to the angle whose tangent is -1. The range of inverse tangent is between negative pi over 2 and pi over 2. So the inverse tangent of -1 has to be between negative pi over 2 and 0. So it's negative pi over 4. Okay, in the next exercise, write the expression, the tangent of the inverse sine of x over the square root of x squared plus 9 as an algebraic expression. So we want to find the tangent of the angle whose sine is x over the square root of x squared plus 9. This is one of those exercises where you can use a right triangle as a guide. So this is the angle. The sine of that angle is x divided by the square root of x squared plus 9. And in order to find the tangent of that angle, we need to find the adjacent side. So we can label this A and then use the Pythagorean theorem. So we square the square root of the hypotenuse, we square the hypotenuse. In this case, we square the square root of x squared plus 9. That's equal to a squared plus x squared. When we square the square root of x squared plus 9, we just get x squared plus 9 equals a squared plus x squared. Subtract x squared from both sides, we get a squared equals 9. And we'll just pick the positive solution for the right triangle. And so the tangent then so I'm trying to get out of rewriting that whole thing, but I guess I'll just do it. The tangent of inverse sine of x over the square root of x squared plus 9, the tangent of that angle is x over 3. Okay, and the next problem, the Washington Monument is 550 feet tall, 555 feet tall. Find the angle of elevation of the sun when the monument's shadow is 620 feet. So we can probably do this in our heads, but we'll draw a diagram. So suppose this is the Washington Monument and its height is 555 feet. And the sun in the sky is casting a shadow. Whoops, I should have made the sun higher, but so pretend like that's a straight ray. Okay, we want to find this angle if the length of the shadow at that instant is 620 feet. We can call the angle theta if we want, or any other letter. So the angle of elevation is theta. Well, it looks like the easiest thing to do is to first write the tangent of theta is 555 divided by 620. Notice we don't need the units because the feet units from the numerator and the feet units from the denominator cancel each other out. So tangent of theta is just a number. And then we say theta is equal to the inverse tangent of that number, 555 over 620. Okay, so for our purposes, this is the answer. Don't bother writing the fraction in lower terms. Just leave it in that form. Okay, now we'll get into Chapter 9 material to review. Okay, so this one simplified the expression. This is not an equation, it's just an expression. Tangent of x times cosine of x squared times secant of x. So usually if you just, whenever possible, convert things into cosine and sine, then you'll see what to do. So tangent is sine of x over cosine of x. We'll leave cosine of x squared the way it is for now, but I'll write it as cosine of x squared over 1. And secant of x is 1 over cosine of x. So we'll write it one step further before simplifying. Sine of x times cosine of x squared divided by cosine of x times 1 times cosine of x is cosine of x squared. So those cancel each other out, and so it simplifies to sine of x. Okay, simplify the next one. 1 minus secant of x squared divided by tangent of x minus tangent of x times secant of x. Well, there may be numerous ways to go about it, but it seems like the most straightforward thing to do, based upon what I'm seeing in the denominator. Think of 1 minus secant of x squared as a difference of squares and factor it. So one of the factors is 1 minus secant of x. The other factor is 1 plus secant of x. And in the denominator, we can factor tangent of x out of both terms. So we get tangent of x times 1 minus secant of x. So we at least get 1 minus secant of x divided by 1 minus secant of x out of the way. But it looks like we can simplify further. So I suppose what I would do is, in the numerator, write 1 plus secant of x as 1 plus 1 over cosine of x. And in the denominator, rewrite tangent of x as sine of x over cosine of x. And then in the numerator on top, we'll write it as with a common denominator, which is cosine of x. So 1 plus 1 over cosine of x is equivalent to cosine of x plus 1 over cosine of x. And we're dividing that by sine of x divided by cosine of x. And so if we multiply the fraction on top by the reciprocal of the fraction on the bottom, we get a cancellation. And then we get cosine of x plus 1 over sine of x. So if we break this apart, one term will be cosine of x over, I guess I'll go ahead and write it, cosine of x over sine of x plus 1 over sine of x. And then the last step, as far as I can tell, cosine of x divided by sine of x is cotangent of x. And then 1 over sine of x is cosecant of x. That's what I get. Okay, the next one, verify the identity. 1 minus sine of x over 1 plus sine of x equals the quantity secant of x minus tangent of x squared. So I think what I will do, I'm going to start with the right-hand side and see if I can get the left-hand side. So I'll start with secant of x minus tangent of x squared. Okay, before squaring, I'm going to rewrite what's on the inside. Secant of x is 1 over cosine of x. And tangent of x is sine of x over cosine of x. And I have a common denominator, so I'm just going to write it as the quantity 1 minus sine of x over cosine of x squared, quantity squared. And before squaring, I'm going to replace cosine of x with 1 minus sine of x squared. So we can write this as, in parentheses, 1 minus sine of x over 1 minus sine of x squared, all squared. Okay, so then we get 1 minus sine of x. I'm going to factor the denominator, 1 minus sine of x squared. One factor is 1 minus sine of x. The other one is 1 plus sine of x. And if I cancel those, I get, oh, and this is supposed to be squared still. So I just get the quantity 1 over 1 plus sine of x squared. Okay, so when I finally square it, I get 1 over the quantity 1 plus sine of x squared. So now I'm confused. Maybe if I multiply by 1 in the form 1 minus sine of x over 1 minus sine of x, well, I'm stumped at the moment and I'm running out of room. So let's move on to the next example. Maybe something will come to mind in a minute. So let's see if we can verify this one. Since the right-hand side is cosine of x, it looks like we should work with the left-hand side. So if we start with the left-hand side, we get 1 minus sine of x squared over 1 plus cosine of x. And if I write it as with a common denominator, so I'll multiply 1 over 1 by 1 plus cosine of x over 1 plus cosine of x. So I'll get 1 plus cosine of x minus sine of x squared divided by 1 plus cosine of x. Since we want to end up with cosine of x, I suspect that we should replace sine of x squared with 1 minus cosine of x squared. So we have 1 plus cosine of x, and you have to be careful, especially when you're subtracting. So we're going to subtract what we get when we replace sine of x squared with 1 minus cosine of x squared, all over 1 plus cosine of x. So 1 plus cosine of x, and then distribute subtraction. We have minus 1, and minus is plus cosine of x squared, all divided by 1 plus cosine of x. The 1 minus 1 cancels, so we get cosine of x plus cosine of x squared divided by 1 plus cosine of x. And then in the numerator, factor cosine of x. Factor cosine of x out of both terms. So cosine of x times the quantity 1 plus cosine of x divided by 1 plus cosine of x. The 1 plus cosine of x divided by 1 plus cosine of x cancels, so we end up with cosine of x. Okay, I just noticed a question. How do we write the equations of the asymptotes? I'll bring back that one example. Maybe that question was asked before I answered it. Remember this example on the graph of y equals negative 3 cosecant of x minus pi over 2. We have a asymptote where x is pi over 2, 3 pi over 2, and 5 pi over 2. So the equations for the vertical asymptotes are x equals pi over 2, x equals 3 pi over 2, and x equals 5 pi over 2. So in general, if you're graphing something in the xy plane, and if there are vertical asymptotes, the equations will always have the form x equals whatever the number is that it corresponds to. So I hope that clears that up. Okay, section 9.2. Find the exact values. Well, remember from section 9.2, we have the sum and difference formulas. So I'll write the sum and difference formulas up here. The difference formula for cosine of alpha minus beta. So by Monday, make sure you have this one memorized. Cosine of alpha minus beta is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. The cosine of alpha plus beta, the only difference is that we have subtraction instead of addition. So this is the formula that we can use to evaluate cosine of 15 degrees. And it says find the exact values. So we want to find two angles whose difference is 15 degrees. And the two angles should be special angles. So two angles that are special angles are 45 degrees and 30 degrees. And 45 degrees minus 30 degrees is 15 degrees. So cosine of 15 degrees is equal to cosine of 45 degrees minus 30 degrees. And then we apply the difference formula. So we get cosine of 45 degrees times cosine of 30 degrees, and then plus sine of 45 degrees times sine of 30 degrees. Cosine of 45 degrees, square root of 2 over 2. Cosine of 30 degrees is the square root of 3 over 2. Sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. And the common denominator is 4, so we can write a single expression with a denominator 4. Square root of 2 times the square root of 3 is the square root of 6, and then plus the square root of 2. Okay, in the next example, sine of 11 pi over 12. So we can use the sum formula for sine. So I'll rewrite that up here. If you have sine of alpha plus beta, this is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So we want to find two special angles that add up to 11 pi over 12, or special enough anyway. So it looks like 3 pi over 12 plus 8 pi over 12 equals 11 pi over 12. 3 pi over 12 is pi over 4. And 8 pi over 12 is 2 pi over 3. So we'll think of this as sine of pi over 4 plus 2 pi over 3. Okay, so this will be sine of pi over 4 times cosine of 2 pi over 3 plus cosine of pi over 4 times sine of 2 pi over 3. Sine of pi over 4 is the square root of 2 over 2. And cosine of 2 pi over 3, 2 pi over 3 is in the second quadrant, and cosine is negative in the second quadrant. The reference angle is pi over 3, and we know that the cosine of pi over 3 is 1/2. So cosine of 2 pi over 3 is negative 1/2. And then cosine of pi over 4 is the square root of 2 over 2. And sine of 2 pi over 3, sine is positive in the second quadrant, so this will be equal to sine of pi over 3, which is the square root of 3 over 2. And the common denominator is 4. We can put the positive number on the left. Square root of 2 times the square root of 3 is square root of 6, and then minus square root of 2. Okay, the next one's find the exact values. So on this one, we're just going to work in reverse. Sine of 25 times cosine of 35 degrees plus cosine of 25 degrees times sine of 35 degrees. This is what we get from the sum formula for sine. So this should be equal to the sine of 25 degrees plus 35 degrees, which is the sine of 60 degrees. And we know that the sine of 60 degrees is the square root of 3 over 2. Okay, so this is using the sum formula for sine in reverse. Okay, this is the sum formula for cosine in reverse. So just to remind you, up here I wrote the difference formula for cosine, but the sum formula for cosine, cosine of alpha plus beta is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So this one is just going to be the cosine of 99 degrees plus 36 degrees, which is the cosine of 135 degrees. 135 degrees is in the second quadrant, and cosine is negative in the second quadrant. The reference angle is 45 degrees. So cosine of 135 is equal to the negative of cosine of 45 degrees, which is negative square root of 2 over 2. Okay, find the exact values. So tangent of 7 pi over 12, and then tangent of 15 degrees. So we'll want to remember the sum and difference formulas for tangent. On this one, we'll use the sum formula. So I'll rewrite that here. Tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta. So we can think of tangent of 7 pi over 12 as tangent of a sum. So 3 pi over 12 plus 4 pi over 12. But 3 pi over 12 is pi over 4. And 4 pi over 12 is pi over 3. So we just apply the sum formula. So in the numerator, we get tangent of pi over 4 plus tangent of pi over 3. And in the denominator, 1 minus tangent of pi over 4 times tangent of pi over 3. Okay, the tangent of pi over 4 is 1. Tangent of pi over 3 is the square root of 3. And then in the denominator, 1 minus the tangent of pi over 4 times the tangent of pi over 3. So this will be 1 minus 1 times the square root of 3, or 1 minus the square root of 3. Okay, for this one, we'll use the difference formula for tangent. We saw earlier that 15 degrees is 45 degrees minus 30 degrees. So tangent of 45 degrees minus 30 degrees. So the difference formula for tangent. Okay, so the difference formula for tangent of alpha minus beta is equal to tangent of alpha minus tangent of beta divided by 1 plus tangent of alpha times tangent of beta. Okay, so we get tangent of 45 degrees minus tangent of 30 degrees divided by 1 plus tangent of 45 degrees times tangent of 30 degrees. So tangent of 45 is 1. Tangent of 30 degrees is 1 divided by the square root of 3. And in the denominator, 1 plus 1 times 1 over the square root of 3. So this can be simplified to the square root of 3 minus 1 over the square root of 3 plus 1. Okay, let's work on this last problem. Use the sum and difference formulas to simplify. So we'll use the sum formula for cosine to simplify cosine of x plus pi over 3. So this is cosine of x times cosine of pi over 3 minus sine of x times sine of pi over 3. And then from that, we are subtracting everything we get from cosine of x minus pi over 3. So we'll put all of this in parentheses since we're subtracting it. So cosine of x minus pi over 3 is cosine of x times sine of pi over 3, and then plus sine of x. Sorry, I messed this part up. This is minus cosine of x times cosine of pi over 3 plus sine of x times sine of pi over 3. So we're running out of time. Cosine of pi over 3 is 1/2, so we get 1/2 cosine of x. And minus, since the sine of pi over 3 is the square root of 3 over 2, we get minus the square root of 3 over 2 sine of x. And then we're going to subtract this quantity. Cosine of pi over 3 is 1/2, so we're subtracting 1/2 times cosine of x. And we're also subtracting the square root of 3 over 2 times the sine of x. So these two add up to 0, and we end up with a total of negative square root of 3 sine of x. Okay, we're out of time for today. We went over just, well, pretty much everything that we needed to. We didn't graph everything, but keep working, and I'll send information about test 2 and the Zoom meeting. But that's all for today.